So little review first. What is a vector? Yeah, it has what we call magnitude and a direction. Example, 30 meters per second. Uh-oh, where's my rate? There it is. That is just a magnitude. It's just a number. There's no direction with that. So that's what we would call not a vector, a scalar. If I put west or 30 degrees north of east or just right or even that way, well, that's a direction. So now it's a vector. I have a magnitude and I have a direction. Okay, so some examples. What are vectors? Because just the word acceleration, we're telling you that is a vector. So when we say what is the acceleration, technically you should have a magnitude and a direction, but sometimes we get a little lazy. But that by definition is a vector, okay? 28 meters a second squared, right, north. Velocity, that word is a vector because we also have the non-vector form of velocity. What do we call that? Yeah. So a scalar for velocity is speed. That's just the speed there. That's just the number, the magnitude. Okay, force is a vector. What unit is force in? Newtons. So 35 newtons. Just ask yourself the question, could I have a direction? I could push this table with 35 newtons this way, and that's probably the way it'll go. I could push it this way, and it'll go that way. Okay, there is some direction there. Okay, displacement is the new word in Physics 11. Okay, what is the non-vector form of displacement? The scalar of displacement is distance. Yeah, if it's just a distance, it's 40 meters. If we have a direction, I walked 40 meters towards my house. Now I have a direction, it's a displacement. So some of these have the scalar and the vector form. Some of them kind of don't. Okay, how about weight? Is that a vector or is that a scalar? Could I have a direction for the weight of this thing? Yeah, this would fall down exactly towards the center of the Earth. Center of gravity, center of mass, sorry, of Earth, right? Which is dead center. That's the direction they always go when you drop them. That does have a direction. That is a force, isn't it? What's the force of gravity? mg. That's also known as weight. Weight is in what units? Newtons, just like force. Now, when we're talking about weight on Earth, we usually confuse that with this other word, right? Yeah, because if you're 80 kilograms, does that have a direction? No, that's the amount of matter that someone has, the amount of atoms. You're 80 kilograms on Earth, you're 80 kilograms in space. You're 80 kilograms everywhere. So no direction doesn't really make any sense. What else doesn't make any sense? And you might argue with this, but time doesn't really have a direction. And I know most of it came off of relativity, and we argued that you can actually slow it down. You may possibly theoretically be able to stop it, and then we had this argument in some of the questions on the test. But anyway, it doesn't have direction. Doesn't really make any sense. Okay, speed, distance, time, mass, that's the common ones. For vectors, acceleration, velocity, force, displacement, weight as well. Okay, that's about it. But just ask yourself, does it have a direction? And then you can tell if it's a vector or a scalar or not. Adding vectors. Okay, we add them tip to tail. And that has no meaning until we tell you that's how we do a symbol for a vector. It's an arrow. So now you know an arrow has a tip and it has a tail. Okay? And this isn't Physics 11 material, but most teachers introduce it at least. So I did introduce it to you guys. So you remember the good old riverboat question? Oh yeah. You wonder why that wasn't on the test? Because it's not Physics 11. It's not one dimension, it's two dimensions. It's actually Physics 12. But it's good to introduce you to it, because then it saves us like 3 days of trying to reteach this stuff. Okay, so we have some river. All right, and I know I got a boat that travels in still water at 4, I'm not going to put units. Might be meters a second, might be kilometers per hour, okay? But I know I have some boat that can travel at 4 meters. Well, no, I said I wasn't going to do units. 4. Okay? Now in still water, we all know what's going to happen. It's not a surprise. I could ask some grade 4s across the way here, and they'd be able to tell me what's going to happen. Gets a little more confusing when we have a river here, and to be kind of accurate, if that's 4 and that's 3, then that one should be a little smaller than that one. If the river's flowing, intelligent grade 4s would still be able to tell me what happens with this boat. But I wouldn't even begin to try to teach the math of that, right? But they'd be able to tell me, where does this boat end up? Does it end up at A? Does it end up at B? Or does it end up at C? And Reese there in grade 4 would put up his hand and go, Mr. Watson, I think it goes to C. And I'd say, yes, Reese, you're right. That's where it would go. Okay, because what we learn is we can add these together. So to do this picture again over here, I want to make that nice and big. That's 4. And I'm going to add this vector, tip to tail. Don't be lazy. Put arrowheads on here. Because if you don't, you're going to make a mistake. Just like yesterday, some of us, I'm not going to do those stupid fractions. I know how to do that. But then you get into some big rational polynomial, and oh, how do I do this? Because you didn't practice the easy stuff, now you don't know what to do in the hard stuff. Okay? So even if you know what the answer is here, and most of us do, what is the resultant? 5. That's our carpenter's triangle, right? Okay? What you did is you memorized that, but again, this is just Pythagoras. There's my right angle. 4 squared and 3 squared equals the resultant squared. So the resultant, again, for someone who hasn't seen that before, that's the answer. That is the hypotenuse here. The answer, when I add these two vectors, tip to tail, is the resultant. Here we know it's 5. And is that a vector? Yes. So is that the full answer? No, it's not. Whatever unit this is, meters a second, kilometers an hour, I don't have a direction here. So remember how I get the direction. Let's call it theta. Again, SOHCAHTOA. I know the tangent of theta is, label the triangle, that's hypotenuse, that's an opposite, that's an adjacent, so I want to use tangent, okay, because I didn't know what 5 was yet. Okay, so that is 3 over 4, O over A, TOA. And what button do I push on my calculator when I don't know the angle? Inverse tangent. I guess I'll do it here. Make sure it's in degrees. I did tell you the story about in this course, one girl whose battery went dead, and I guess the internal battery went dead too. She changed her batteries. She brought her calculator to the test. We were doing lots of trigonometry. It was in radians. She got 23% on it. Didn't realize that answer doesn't really make sense, but okay, that's what I got. I'll check it again. Yep, I got it again. Okay. And it always, this calculator, this isn't a real calculator, this is a program. So every time I turn it on, it defaults to radians, right? Okay, yours won't unless you go change the batteries, all of them, or somebody steals it, like Jeff here would do something like this, right? And change it on you and then give it to you on your test. All I'm going to say is just, it's nice to check, right? Because guess what she said when I noticed when I marked it, I think your calculator was in radians, not degrees. Oh, well, what do I do now? You do a rewrite in a month and a half? Like, sorry, this is physics 12. Like, I can't, make a special exception just because she should have noticed. All of her answers didn't make sense. And even though she did it right and correctly, I still couldn't give all the marks for it. Anyway, I was going to do that. Inverse tangent of 3 divided by 4 is 37 degrees, nearest degree. Does it look reasonable? Sure. Okay? So 5, whatever units that is, at 34 degrees, but which way? According to this picture, thank you, 37. 37 degrees, according to this picture, that's what? It is eastward of north. Okay? So you look here at this one first. You go, it's not due north, it's 37 degrees east of it. Okay? But again, we could have drew this picture 8 different ways. Well, maybe 4. Okay, so again, when I'm asking the question, unless I said the boat went north, the river is flowing east, which I will on the test, okay? That would be the right answer, but there might be more options. Okay, that now is a vector. I have a magnitude and a direction. Okay, but I'm emphasizing to add vectors, it's always tip to tail. Your resultant, let's make a note of this, will always go from the beginning of the first vector to the end of the second one. I don't think we'll have 3 to add, but it's possible. It would go to the end of the third one. If I got a boat going that way and a river going this way and the wind going that way, well, my resultant always goes from the beginning of the first one to the end of the last one. Okay, but we're going to add some of these things. I'll show you how. Okay, so it goes from the tail of the first vector to tip of the last. Now I have to actually think about that when I write it down. But some people like words instead of pictures. I just know as a picture, a lot of you would just, okay, now I get it. All I have to do is show you that. Okay? But when you add these wrong, okay, you're going to get the wrong answer. Is there another way to add these 2 vectors? This 4 and this 3? There is, right? I know that's going to go like that, but is the water flowing here more quickly than it's flowing here? No. I could add this down here, but see, what's wrong with that picture? Those vectors are not added tip to tail. They're added tail to tail. So you're going to get a wrong answer here, but you can add them tip to tail like that. And then the resultant goes from this one to that one. Does that look the same as this? Yes, it does. Okay, so there's no, I can't tell you this is righter than this way. I just happened to put my 3 up here. I could have put it down here. Just make sure you add them tip to tail, and then you won't make a mistake. Your resultant goes from the beginning to where you end. That's actually better wording than this. Okay, goes from where you started to where you ended up. Okay, so some of that is a little bit of review, but again, it's not technically physics 11 stuff. Now it's physics 12. No excuses. Okay, example. Let's do a second page. Couple of examples. For a projectile, and that's a word for lots of stuff. A rocket, a baseball, a football, my eraser, okay? A bad kid who I threw out of my classroom. Any projectile. Shot at, and we usually assume gravity acts on it. Okay, I don't know, if I throw something in space, is it still a projectile? No. I don't know the answer to that question. This is something professors would argue about for weeks. and they would love every minute of it. Okay, anyway, this thing's got a magnitude and a direction. 30 degrees above the horizontal. Does that make sense to you? I started in capital and I went to lowercase. 30 degrees, okay, do we know what a horizontal is? Where's Sarah? She's not in this class. It's just something, some people, yeah, I keep saying to her, oh, maybe, I don't know, maybe 9 times. You sleep horizontally, you walk vertically. Okay, now she gets it for another day. That's horizontal, right? Look across the horizon, horizontal, right? We all got horizontal, vertical. So if this thing is 30 degrees above the horizontal, or 30 degrees to the horizontal, that's like an angle of elevation. Okay? I could have used those words also. 20 meters a second. This is a vector. Okay, and this vector happens to be velocity. So you write that here. This has 2 components to it, and you're going to do this lots in kinematics. This is how you're going to solve problems. Because in Physics 11, like I said, it was always straight up and straight down. You didn't have to worry about some angles. This is already the resultant. Okay, so I'm kind of going backwards here. Here I gave you the y and I gave you the x and said find the resultant. Now I'm telling you the resultant, guess what we got to do? I want to find the x component of that and I want to find the y component of that. Okay? So if I took this vector and I took that vector and said find the resultant, that's what we've done. Now I'm just going backwards. So I'll call that Vx for the velocity in the x direction, and I will call this Vy for the velocity in the y direction. And this is just simple SOHCAHTOA. Okay, we can figure this out. So first, slowly, I will go and label my triangle, and then after a while, we're just going to, boom, you're going to know your x component is cosine, and you're going to know your y component is sine, and hopefully be a lot quicker, okay? For this angle, that is the opposite, so this is the adjacent. So how do I find out Vy? Well, opposite, I'm trying to find, I've got hypotenuse, so that's the one I want to use, so, and the sine of 30 degrees is Vy, that's opposite, over hypotenuse, that's 20, and how do I solve that for Vy? Multiply both sides by 20, right? That's gone. So Vy, the vertical component is 20 times sine 30. And if we're really good in math and we remember this stuff, what is the sine of 30, Jake? What? No. You don't remember that? You just came out of math. That's why I'm bugging you. Anyone remember sine 30? Yeah, good. Yeah, one of my kids, huh? Okay, so anyway, that's 10, isn't it? What? Let's prove it. 20 sine 30. Sine 30 is a half. That's a special triangle. Those of you in Math 12, you're going to know this stuff. Or else. Okay? That is 10. And I know I have units here, so that is 10 meters a second vertically. So when this thing goes like this, you can think of it going up at 10 meters a second. That's how you're going to solve for problems like how high does it get? How long before it's at the top? Okay? Because I don't care about the horizontal. All I care about when this thing gets as high as it gets, okay, right at the maximum, is this component. Make sense? You have to detach the horizontal from the vertical. They're independent of one another. Okay, that's a difficult concept for a lot of kids. Anyway, Vx, what do I do there? Well, I'm going to use A and H, that's cosine. So I know sine of 30 is Vx over 20. Same procedure, multiply both sides by 20, and the x component of this velocity will be 20 cosine, right? 20 cosine 30, not sine. Yeah, that one's root 3 over 2. That is 17.3 meters a second. And why would I want to know that component? Well, yeah, that tells me how far along the ground this thing goes. If I know the time it takes vertically before it hits the ground, well, isn't that how long it's going to go from here to here? It is, okay? But we're not in kinematics yet. Okay, so this is what's called, we don't have to write this down, but as far as some of the learning outcomes in Physics 12, it's breaking down a vector into its orthogonal components. I know x component and I know y component. Okay? Couple little things and then you can start working on your big worksheet. So that's the math stuff. Let's write, this would be like a multiple choice question. Okay, so I have A, that's vector A, that's vector B, this is vector C, and this is vector D. Example. If I add A and B, is the answer C or is it D? This is just a visual exercise. Nobody likes D? Okay, that one's not too bad, right? You can visualize this thing added to this, tip to tail. And it's easiest if you take that and you stick it right there, and it looks like the answer would be C, right? More or less, but not D. We're okay with that? Could I also take this and add it over here? Now don't do this on your page, but there's B. Would the answer still be kind of C, more or less? Yeah, okay, so again, I'm emphasizing there's more than one way to add two vectors, right? There's two ways. Now, something a little tougher. I'm sure you all can handle it. What's A minus B? And so what do I mean by minus B? I don't really want to subtract these vectors. The thinking is this is the same as A and negative B, right? Like mathematically, isn't this equivalent? So this is B, but you need to think of it as positive B. So if this way is positive, then negative must be 180 degrees the other direction, right? So negative B would be exactly the same length, but the other direction. What would the answer to A minus B or A plus negative B be? Yeah. Does that make sense? If I take that one, let's use my tool, and I add that tip to tail with that, and it doesn't really, I didn't draw this correctly, but it's definitely not C, right? Let's fudge it a little bit. That's equal to D. Okay? That's how we do that. We don't really want to subtract. We want to add the negative. Recall. A change in a velocity is final minus initial. Right? We've seen that before? Rings a bell? And we did that complicated question where it's talking about kinetic energy, and I said, well, you don't want the change in the kinetic energy. That's the work done. So it's 1/2 mv squared final minus 1/2 mv squared initial. Well, let's take this to a new level. A plane flies due west. You know what that means? Sure, left if you're assuming north is up. Yeah. Due west. Means towards west. A hurricane blows, if they blow, do they blow? Or they just occur? Do they just happen? I don't know. What's the word? A hurricane blows and it ends up going not the way you wanted. South. So what's the direction of the hurricane? Northwest, southwest, northeast, or southeast? And some of you guys may be able to do this in your head, and that's fantastic. But I've seen some guys do it in their head, and everything's all good, and I get it, and then on the test you make a mistake, and oh, whoops, and you missed an easy mark, because you didn't do it with the procedure that I'm kind of teaching you how to do it with, okay? Well, let's find out what goes on. So a plane flies due west. That's the plane, right? So looking at this, which one is that? Initially, the plane is flying west, right? So that's VI. It ends up, after the hurricane blows on it, a change happens, and it ends up going south. That's final. So just look at the formula. I know this, I know that, I'm trying to find this, right? So now that you have these two pictures, are you able to visualize what direction would make sense here? If it is initially going like this guy, and then it ends up going like that, you like that? Okay, so you might get the answer just by doing that and doing like a picture's worth 1,000 words. You hear me say that before? But now if some of us don't get that, well, let's look at the formula. VF minus VI. I got VF, I have VI. What's minus VI? That's minus VI. If I add this and this, I get the direction. Let's add this and this. What's the direction? That's delta V. That's definitely southeast, isn't it? Okay? So, just because you think you can do that, just to warn you, I still recommend you doing it like that, because maybe you get one on the test that you can't really figure out, or you easily make a mistake. Okay? And that should be one of the marks we want to get. So I'm going to say do half of the worksheet. The worksheet I'm going to give you is 2 days worth of stuff. Okay? Save the ones with an R for last. I'm going to give you just one more example tomorrow. It's going to be about 5-10 minutes, and then lots of time to work on it still. Okay? It's a 2-day worksheet.